Okay, so now that we've learned about lines and line segments, we're going to talk a little more specifically about just line segments. And we're going to need to learn some words and learn what they mean, and then learn how to do some drawings, and it should be pretty easy stuff once you get comfortable with it. So one word we need to learn is the word between. And I know you probably know what between means, but in geometry it has a very specific definition. Point, we'll call point M, is between points P and Q if and only if P, Q, and M are collinear and the distance from P to M plus the distance from M to Q equals the distance from P to Q. So what that means is we have a line, and somewhere on that line we have a point called P, and we have another point called Q. The only way that we can say that M is between P and Q is if it's actually on the line. If we had another point up here, you don't need to draw this, but if we had another point here, this point you could not say it's between P and Q. So they have to be on the same line. It doesn't seem like a big deal, but it's actually very important. And what we're going to do here is try to make a connection that the distance from P to M, that's this distance, plus the distance from M to Q, right there, is always going to be equal to the distance from P to Q. So let's look at this first example. It says to find AB. So that means we want to know how far is it from A to B. Well, the easiest way to do is to just write out that AB plus 5.8 equals 13.2. And hopefully you can see that from A to B and then from B to C is going to have to equal A to C. And then we just solve this small algebra equation. So we subtract 5.8 from both sides, and we come up with AB is equal to 7.4. And that's our answer. And remember, this AB means the distance from A to B. And that's just how we write it. AB, there's no line above it, no mark above it, and that's it. All right, so move down, we'll try one that's a little more complicated. Our sentence here says M is between N and O. Find the distance from N to O. So they want to know, how long is this? Well, you see right here it says it's 5x plus 2, but I don't know any tape measures that'll tell you something's 5x plus 2. So we've got to figure out how to figure this distance out. So hopefully you're starting to see that N to M plus M to O would have to equal N to O. So we're just going to write out exactly what we see here, that 17 plus 3x minus 5 has to equal 5x plus 2. And so this is a typical algebra problem like we practiced the last week. We're going to start to combine things first. So now we have 12 plus 3x equals 5x plus 2. And then we're going to start to move things. So we're going to subtract 3x. We're going to get 12 equals 2x plus 2. We're going to subtract 2. We're going to get 10 equals 2x. Now instead of just continuing to write and trying to jam this in on the bottom of the page, I'm going to indicate that I'm moving my work up higher, which is something you should do when you run out of room. Don't just start writing somewhere else because it makes it hard for anybody to follow what you were thinking. So I'm going to have 2x equals 10. I'm going to divide both sides by 2 and come up with x equals 5. And what's going to happen on a test is you're going to come up with that and you're going to put a box around it, and you're going to be done. And then, unfortunately for you, when I grade it, I'm going to have to come through and mark it wrong, because the question says to find out how long the distance from N to O is. So we're almost done. We just got one more step over here. We know that N to O equals 5x plus 2. We have to take this value we found for x and plug it in. So it's 5 times 5 plus 2. So N to O equals 25 plus 2. So your final answer would really be that N to O, or NO, equals 27. Moving on, we come to something called congruent segments. Now, you've probably heard the word congruent before, and you've heard that it means same size, same shape. If you have two segments like these over here, AB and CD, these are congruent segments. So congruent segments are segments that have the same measure or length. The way you would say it is segment AB is congruent to segment CD. The symbols that you use for congruent is this symbol. It's an equal sign with a little squiggly line on top. And what we would write is AB is congruent to CD. What that means is the distance from A to B is equal to the distance from C to D. And just to get it in your brain now, that writing this is no good. That's not a rational statement, because AB with a bar on top means segment. AB without a bar on top means distance. So this actually represents a number. So just keep in mind, and also if you wrote this, AB is congruent to CD, that also would be incorrect way to write this. So keep in mind, if you're going to say congruent, you got to have a segment. If you're going to say equals, you have no segment. Something else, these little marks right here, these are called tick marks, okay? I don't know why they're called ticks, maybe because when you make them, your pen makes a little tick sound, I don't know. But these are called tick marks, and they indicate that two segments in a drawing or in an illustration are the same length. So anything in a picture that has one little mark on it, they're the same length. If we had another segment that we knew were the same length, but they weren't the same length as this segment, they would get 2 marks. And you just keep going. You do 3 marks and 4 marks, and most pictures won't have more than 3, but that's how we indicate they're the same. All right, moving on, we've got one more page. We're almost done. We're going to talk just for a minute about distance. The distance between any 2 points is the absolute value of the difference between their coordinates. So if P has coordinate x1 and Q has coordinate x2, then the distance between P and Q, and you have to learn to understand this language like this. We're going to practice it a lot, so don't get too stressed out if this doesn't make any sense right this minute. But the distance between P and Q is PQ. We already know that part. But this up here, the absolute value of the difference between their coordinates, that means that the distance from P to Q is the absolute value of the difference between their coordinates. So if point P is -6 and point Q is 1, then it's the absolute value of the difference between those two numbers. The distance between P and Q is also called the length of segment PQ. So it's all vocabulary, it's all on how you say it. I promise this is very simple. First example says find BE. So find the distance from B to E. Well, a very easy way to do that would just be to count that it's 1, 2, 3, 4, 5, 6, 7, 8. But if these points weren't close together, it might take you a while to count it. So we're going to do it without counting. So the distance from B to E is the absolute value of 2 minus -6, because it's kind of like from our formula up here, I'm going to make this my x1 and this is my x2. It's just two numbers that are different than each other. So one of them is x1 and one of them is x2. Now I know from algebra, absolute value means anything that's inside these bars is automatically going to be positive. So the absolute value of B to E, the length of BE, equals 8. It wasn't a big deal to have the absolute value on this one, but if this had been a negative number, we would have put a positive there. Last one. Why don't you go ahead and practice this one, and when you come into class tomorrow, we'll go over it and make sure everybody's feeling good about it. Have a great night.